So we're looking at the surface area of a sphere. And what part, like where do you guys know this part of the formula for? A circle, what of a circle? So pi r squared is what? Area of a circle. Okay. Now, how do you find the area of a circle? What do you actually need? You need a circle. And what measurement do you need from that circle? The diameter or radius. If you have the diameter, then you can divide it by 2 and get the radius. If you have the radius, then you're just good to go, right? So now, this formula implies that there are 4 circles within that if you have 4 circles made from, like, say we've got our orange, right? So if I have a circle, well, let's try to, oh boy, giant hand in the way. Here, I think I should hold this. I don't know how well this is going to work. You have to bear with me. Okay, so let's say that's my circle, approximately. Now, how would I find the area of this? Let's say, take that, call that R, and then if I find the area of this and then multiply it by 4, I should get the surface area of my sphere or my orange, right? How accurate do you think that is? Like, how many circles should I end up with if I were to peel this and place this on here? Do you want to try it? Do you guys want to sit here and watch me peel this orange? Yeah? Okay. Oh my gosh, I did not plan for this. How am I supposed to do this? This is going to get messy. This was a bad idea. Okay. Now, you have to be really careful when you're peeling this. If you guys want to do this yourself at home. I'm regretting this already. Okay. See, now, why is this not really going to be that, like, it's going to be close, but what can you see that's happening? There's, like, some spaces and holes and stuff, right? How do I fill in these little holes? A couple more. Would you say that that's like one circle? Is that good enough? Yeah. Okay. So I'm going to move this out of the way. Call that 1. I'm trying to, so that was 1, right? How did I measure the circumference? Okay, so here, 1, 2, 3, 4, 5, 6, 7. Because I want 4 of these circles, right? Let's see if this works. So how long is it supposed to rain today? Is it supposed to rain all day? Do I have too much overlap on this one? Okay, so is that close enough to one circle? Is that close enough? Okay. And then, so we'll move it here. Do you guys think it's going to work? I got a big piece there. I don't know. Okay. Okay, so and now we've got, there's that weird nubbin piece. Okay, that one's less so, but I kind of overfilled another one, right? So I've got like, there, I can fill that one up a little bit more. So there's like, and it's not perfect, right? It's by no means perfect at all. But if you've got a material that is thinner, that you could lay flatter, that you could fill up all the holes, where you could have it kind of exactly, it does work out pretty cool. So there, it's kind of like ish with a orange, okay? Okay. All right, so I'm going to take this mess off here. And then let's try some of these here then. All right, so the diameter of a softball is approximately 4 inches. Determine the surface area of a softball to the nearest square inches. So here we need surface area of a sphere is going to be 4 pi r squared. We have diameter is 4 inches, so what do we need? So we need r is 2 inches. And that's what we're going to use in our formula. So we've got 4 pi and then 2 squared. And that's going to be 4 pi times 4, 16 pi square inches. And if we throw that into our calculator, we will get 50.265 and so on inches squared. Okay, so make sure that your units, you're squaring your units for surface area. And it says nearest square inch, so that's whole number. So 50 inches squared. All right. And then the next one says surface area of a soccer ball is approximately 250 square inches. What surface area, the surface area of a soccer ball is approximately 250 square inches. So they're giving us the surface area now. What is the diameter? So we need to find diameter, okay? Now the formula we have is 4 pi r squared, and they're saying that it's equal to 250 inches squared. So we need to isolate r somehow. Since 4 pi is multiplying by the r, we divide 4 pi on both sides. And then we get r squared is equal to 250 over 4 pi. Okay? And then in order to isolate r, what do we need to do to both sides of this? Square root it. So r is equal to 250 divided by 4 pi. And then what do we actually get when we type that into our calculator? We get 4.4603 dot dot dot. What did the question ask for? Radius? No, it asked for diameter. So multiply diameter equals 2 times r, which it's going to be 2 times 4.4603. And so our diameter is equal to 8.9 inches. All right. So that's the nearest tenth of an inch. And then we have a question about the moon and how the moon approximates a sphere. So that means it's a sphere-ish, kind of a sphere, right? It's close enough. It's pretty hard to get things that are that giant to be exactly spherical. Now, the moon approximates a sphere with a diameter of 2160 miles. What is the approximate volume of a moon? Okay, so now volume has the formula 4 over 3 pi r cubed. All right. Now, if we're given the diameter, we need the radius, right? So diameter equals 2160. Radius equals 2160 divided by 2. And then, okay, so that's 1080 miles. Okay. So that's as simple as substituting that into r. So volume equals 4/3 pi r and cubing it. So we get a ginormous number, 5.27669 dot 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 times 10 to the power of 9. And so we could say the volume is approximately 5.3 times 10 to the power of 9 cubic miles. All right. So your calculator display, depending on what kind of calculator you have, is going to be a little different for this. You know when you get a number and it says, let's say it says this number, and then some calculators have it written up, they've got a number written up in the right-hand corner, like a 00. It looks almost like an exponent. That's what it's going to show up as. So you have to just kind of test your own calculator to see what it does. All right. If your calculator can actually give you all the digits, then it might also do that. So you could write it as 5276669. Oh, missed a 6 in there. Here, let's try this again. 527666986 miles cubed. So you could also write that. All right. Now, hemisphere. What's a hemisphere? Yeah. So a hemi is a half. All right. So hemisphere is half of a sphere. So how would you figure out the volume or the surface area of half a sphere? Okay. First, I want you to imagine this first part here. Part A says, what is the surface area of a hemisphere? Now, think of cutting a circle in half, okay? A solid circle. Like if you cut an orange in half, what does it look like? Well, you've got this top sphere part, right? And then you have this bottom part as well that's now exposed. So what can you tell me about the formula for a hemisphere? You've got half of the 4 pi r squared, right? You've got half of that. But now, didn't we expose something extra? This circle at the bottom here, right? So then we're going to add on a 4 pi r squared. So altogether, what is this formula? What does this reduce to? 2. So you have 2 pi r squared plus pi r squared. So what is our formula going to end up being? 3 pi r squared for surface area of a sphere. So let's do part A over here and use 3 pi r squared to get our answer. Okay, so it has a radius of 5 centimeters. All right. Substitute the 5 in for r, and we end up getting 235.619. So we can say approximately 235.6 centimeters squared. That would be our surface area of my hemisphere. All right. Now, what is the volume of a hemisphere? So the volume, that's easier, right? We can take the volume formula and then divide it by 2 or multiply it by a half. All right. So is there a way that we could simplify this here? Can I reduce a 2 out? So then I'm left with 2 over 3 pi r, and instead of r, I'm going to write a 5 in here right away. And then that's going to give me approximately 261.7993, which is 261.8 centimeters cubed. All right. Okay, so that's pretty much it, folks. The homework for that is right here. Okay, so make sure you guys get that done. Yeah.